Hello guys, and welcome back to another e-bike video, and this time we're going to look at e-bike controllers, and specifically we're going to look at this one. Hopefully you can see this is a KT 48 volt 1500 watt e-bike controller, and what's different about this one is number one, is a little bit more expensive than the one that's in the bike already. But number two, this is what's called a sine wave controller. Now, if you're not familiar with electricity and the way that electricity works, let me just show you what I'm talking about. Right, when you turn the throttle here, that sends a signal through to the controller to drive the motor faster or slower, depending whether you have it cranked up all the way or down or whatever. But what you have here is a DC battery. DC stands for direct current, which just means it's sitting at 48 volts or 50 volts or whatever it is, continuous. But what this motor requires is an AC current, as in the current goes up and down continuously. Now, the e-bike controller sends the AC current, three-phase AC current, to the motor and makes the motor spin. But this controller is trying to take 48 volts or 50 volts, whatever it is, DC from the battery and turn it into AC current or AC voltage. And to do that, it has to do some clever electronics. Now, the clever electronics are either very clever or not so clever, depending on the quality of the controller. So this controller I bought from, I think I bought it from Aliexpress. It was around about £30, $30, something like that. So the reason I bought this one was because it was the cheapest one I could find on the internet. The reason I bought this one is because it promised to be a sine wave controller. Now, the difference between sine wave and square wave, which is basically what this is a square wave going down to the motor goes up, flat, and then down. Flat, up, flat, down, flat. Which basically is not smooth for the motor. It's not the ideal shape of a waveform that the motor wants to see. It wants to see a nice smooth curve. It doesn't want to see sharp, spiky flat bits. So this controller is a cheap square wave controller. This controller is supposedly a much more expensive sine wave controller. It cost, I think, about $110, $120, something like that. I'll put a link to it anyway in the description so you can see for yourself. It did come with a nice controller for the handlebars and speedometer and so on. So it did come with extra stuff, but in the end that is a much more expensive controller than that one. If you're wondering what this is just my other project, which is currently going a bit slowly. But anyway, never mind about that. We're on the e-bike today. The plan for today is to put that controller into that bike with pretty much everything else exactly as it is, so that we can have a direct back-to-back comparison. Which is better? Sine wave, square wave, more expensive, more cheap? What is the benefit of paying the extra? So keep watching and hopefully we'll learn something together. Of course, those are bullet connectors, and those are whatever you call them, ring terminals. So I need to put bullet connectors on this. Yeah, it makes sense to put the other one on first before tightening that up. Let's bring you back out a wee bit so you can see what I'm doing. Okay, so not that it matters, but we'll maintain the colour scheme. The only other thing I need to change, well, two other things. Brake leads. My brake connectors are these. So, although I think I might change that to a smaller, I've got small two-way connectors instead of three-way, so I might change those. And that is throttle, which of course doesn't match that. So I'll have to change that and those. Just leave a wee bit of length on the cable just so that if I ever decide to use that later, I can. And make sure I'm using the right type of connector. There's two types. Don't know if you can see those or not. I better go and check. Yeah, these are the ones I need, the long ones, the long pointy ones to go into this. So what I'll do is I'll crimp this with a pair of pliers, and then I'll put a little blob of solder just to make sure they don't come off, because I don't have the correct crimper for this. So just basically make it up as I go along. Get them into this and I'll come back when that's done. Okay, so now that I've got the pins crimped on and then soldered, just shove them in. At least that's the plan. Get a little push from the end. No, still not in. So the other one I need to sort out is the throttle, which is the wrong type of connector, and I need to make it the same style as this, only with 3 connections. So to do that, I'll use one of these. No, I won't. I'll use one of these instead. So I'll get the pins out for that, and I'll get that one crimped up. Just in case you're curious how I'm doing this, I'll show you how to do just a couple of these crimps. As you can see, They're very small, so the crimping tool for these, I have no idea what it's like. I don't have one. So what I do is I strip the end of the cable, put it in, and then just bend over the first one and crimp it down, and bend over the next one, crimp it down. You need a pair of pointy pliers to do this, and the same with the retaining crimp. Basically just holds the installation of the cable. Bend it down, tighten it up a wee bit. There you go. That's it. Now I could probably just leave it like that, but what I will do is I will get a soldering iron and just put a tiny bit of solder into that, just to make sure that the connection is good, because I do not want to be left stranded somewhere because there's a bad connection on my throttle, because I couldn't be bothered using a soldering iron. That would be kind of silly. So just go out of it, sort of diagonally across it to knock over that high bit, crush it down, do the same the other side, crush it down, and same with the bit that holds the sleeving. Crush it down, square it up a bit because it's usually a bit too wide, and just won't go into the connector if you don't do that. And there you have it. I'll lift that up so you can see it a bit better. They're not perfect, but I've never had one fail yet, so it can't be too bad. And then, like I say, just a little solder, basically just tinning it. There you go. Just enough that it goes into the wires themselves. I have my iron too high up. It's on too hot. I'll just turn it down a bit. If you're wondering how I was able to turn the iron down a bit, I'll show you in a second. There we go. I think that'll do. Yeah, a couple of years ago I made this, which is, it's just a light dimmer switch, and the iron plugs into it, and I use that to turn the iron up and down. Originally this iron came with a knob on it you could turn, but the knob broke off and exposed some live connections. I got the odd dig off that, so cover it in tape and use this instead, and it works a treat. It's just a standard light dimmer switch, and you wire your iron through it and you can adjust the temperature then. So that's that. So now what I have to do is make sure that I put these in the correct way round. So we'll start with a red, which I've just worked out goes to there. And we'll try and push that in and see if it goes in. And the white goes in the middle. If you're ever doing these, always be careful to make sure, remember to put on the seals before you put them in. Probably if I had the correct crimper and wasn't putting the solder on, it would just slide in and click, but slide the little seals in and pop your uncle. Now to just test fit it and make sure I haven't just cocked that up. Right, so now let me see, that is the brake wire that goes in there. And the throttle goes in like so, like so. And I have red to red, white to green and black to black, which I believe is correct. Now that is the, I'm going to have to sort that out. That is the ignition switch. So this one doesn't have an ignition switch. It doesn't need it because it gets controlled by the display. So we don't need that. Don't need the ignition. Sorry, those are the throttle wires, or the, what do you call it, wires? Put that in there. And that in there. That is the hall sensor connection. Which, yep, it's going in. And that is the cruise control. Now my cruise control wires, oh, I'll figure that out. That's not high on my priority list. That is for the, that wire is for the pedal assist, which I haven't put on yet. That'll get happen sometime. And that's power. I need an adapter for that. See if I can find an adapter connection for that. The old one was an XT90 and that one's an XT60. Well, let's do the, yep, that'll do. Nice and small and short. And plug that in there. Plug that in there. And that should be it. Put on this, which is the, I'll just turn that around a bit. This is the display. And if this works, yep, there we go. Let's tell me the battery assist number, speed, motor in watts, temperature, 14 degrees. I'm not sure what that's describing because this garage is quite warm. It's 23 degrees in here at the minute. But let's see if that works. At the back end. Something's not right. It's going to need to be taut, I think, or something. I need to look up the manual on that one. Don't know what just happened there. That's strange. I wonder if I take that hole out and see what happens. Maybe that I'll need to, nope, nothing. I'm going to take the Hall effect out, Hall sensors out. So, try it again. Nothing. I'm trying to swap some of these around just in case it makes a difference. That's good. Haven't that made a difference. Yeah. If you plug one of these in and it doesn't work, play with the phase wires and you get it to work. There we go. Right. I wonder if I turned that up. Let's spin any faster. Won't do. Just a bit. Okay, so next step is to screw this onto here and bring the wires down in. So I'll do that now. Well, unfortunately, my 3D printed light holder is in the way of, just make sure you see what you're seeing. My 3D printed light holder that I use for holding my lights is in the way of this. So I'm just going to have to, I'm going to put it on temporarily, and then I'll either have to redesign the holder for the lights or come up with a different way of mounting the lights and figure out something. But for now I'm just going to mount it temporarily so that I can take it for a spin and see what sort of fun we've got. So I'm going to do that now. Well, as you can see, guys, it's far from neat and tidy, but it seems to be working. I can turn that up and down, and when I have it on number 1 I don't get very much. I'll try and block the sun there. When I have it on number 1 I don't get very much speed, and when I have it on number 5 it seems to get lots of speed. So we'll try it now and see how it goes.